So, a lot of what I'm going to be doing today in class is a lot of talking, okay? I will tell you when you need to start writing things down, but I like to motivate what we're doing and why we're doing it, okay? So, we are going to talk about section 8.3, which is titled Variance and Standard Deviation. You guys will have to compute the variance in your online homework if you are doing the online homework. However, on a test or a quiz, I'll just ask you to do the standard deviation. Okay? One other comment. I will be putting a standard deviation question on next Thursday's quiz. It's not really a type of question I like to ask on a test because it's just a lot of pushing buttons in your calculator. And again, I don't really see it as useful in an exam situation to be pressing a lot of buttons in your calculator. Okay? So you'll see the standard deviation on next Thursday's quiz. All right. So let's start talking about this. And what I'm going to do essentially is talk to you guys about what the standard deviation means, because it's probably a term that you guys have heard of before. And then what we're going to do is we're going to use our intuition to come up with formula for the standard deviation. Okay? You guys are not responsible for that, but you see, if I just wrote the formula out right now, you'd be like, oh my God, where did that come from? Okay, so I like to motivate the formulas, and once we have our formula, then I'll show you how to do the computations. Again, as always, all your formulas will be given to you guys. You don't have to memorize it. All right, well, having said that, let's talk about some things. Last time we talked about the mean, or the average as we know it, and the mean gives us a measure of central tendency but it doesn't give us much information about the data set and how telling the mean is to that data set. And if that just seems like a lot of words, I'm about to motivate this. Okay, let us pretend that I am teaching 3 different classes, and each of these classes has 5 students in them. Okay? So in my first class, all 5 people took a test. And look at what they all got. In my second class, I have 5 students, and let us suppose that their exam scores are as follows: 40, 30, 60, 70, and 50. In my third class, I gave the same test, and look at what their scores are. Tell me when you guys have this stuff written down. I know there's a lot of writing here. Assuming you are writing this, you don't have to. All right. Well, I formulated each of these classes prior so that I could say, I'm really curious, what is the class average? And I claim if you compute the class average for each of these 3 classes, it's actually the same. The mean for all 3 of these guys is 50. believe me, go through and compute it. But not right now. All right. Now, let's ask ourselves what this tells us here. Okay? We look at the first class, and our mean is 50, and oh, that makes sense, doesn't it? Okay? Yeah. Okay? Now let's look at the mean for our second class. Again, it's 50. And would you guys grant me that, yeah, that gives us a pretty darn good idea as to what happened in this class? Wouldn't you agree? Okay? But now let's look at our third class. Does our mean really give us any information whatsoever about that class? No, not really. I mean, okay, fine. People are on either extremes. You compute your class average. It doesn't really tell you and share the information that, wow, some people really knew it and some people really did not. So, while you can compute your averages and it gives you some information, in some places it gives you a lot more information than in others. And what that corresponds to really is how spread out your data set is. Okay? So, what I want to say to you is this. I'm still in search of a good pen here. Okay. If we want to know, or to find how accurate or telling the mean is, we need to find out how much the data deviates from. In other words, we're asking how spread out is the data. Okay, so this kind of motivates where we're going to head. But essentially, and I'm just going to talk while you guys are writing this stuff down, is if the data and the mean are very close together, the mean actually gives you a piece of information. Okay? But if the data is very different from the mean, in other words, if it deviates a lot from the mean, while you can compute your mean or your average, it's not really telling you much information. Okay? So, when we want to figure out how much our data deviates from the mean, or how spread out our data is, what we're actually computing is the variation and then the standard deviation. Okay? Those of you guys who study a lot of things, for example, in the social sciences, if you guys read various studies, you'll see the word standard deviation a lot. Okay? And if you haven't, well, just learn this. So, what I want to do right now is motivate the formula for the standard deviation. You do not have to write this stuff down, okay? So, let us start here. Suppose we have a data set, okay? And I'll write down actual concrete numbers here. But then I'm going to generalize it over there. Okay? So, let's just use our intuition as to what we should do. Well, do you guys agree if really what I'm wanting to know is how much our data deviates from our mean, we should probably compute our mean? Don't you think that's a good first step? Do you guys remember how to compute your mean? Good. What you do is you take all 5 of these numbers, add them up, and divide by 5. If you do that, you'll see that your mean is 46. Okay? So, figure out how much it deviates from our mean is to take each of our data points and subtract off the mean and look at that difference. Okay? So we could do that. And so we could take 32 minus 46. Would you guys grant me that's negative 14? Then we could take our next data point, subtract off our mean. What do you get here? Negative 5. Then you do 47 minus 46, and what do you get? 1. Then 53 minus 46 is 7. And then 57 minus 46 is 11. All right, so over there is a specific example. What I want to show you over here is how we would write this out so far in general. Pretend that these are my data points, x1, x2, all the way out to xn. And let's suppose x bar is 1. Okay? What have we done so far? Well, we've taken our first data point. You don't have to write this down, you guys. Minus the mean. And then didn't we take our second data point minus the mean? And we did that all along to our last data point minus the mean. Okay? You see how we've done that so far? Now, what should we do? Well, one of the logical things we would think to do is say, well, if we want to find out how much our mean deviates from all of our data, we could find the difference just like we did here, and then take the average of those guys. Wouldn't that give us a general overall view of what's going on? So we essentially take the average of our deviations. Okay? If I'm going to take the average of these 5 numbers, how would we do that? You would add them up and divide by 5. What happens when I add up all of these numbers? What do you get? You get 0. Oh my goodness. When you add them up, you get 0. Well, that's actually not surprising, because that's exactly what it means to be a mean. Okay? But I believe that our intuition is taking us on the right track. So, what went wrong here, if there's something wrong, is the fact that we've got negatives because some of our data is less than the mean, and we've got positives because some of our data is greater than the mean. And those negatives and positives canceled each other out. So, then we back up and we ask ourselves, okay, we're in a math class. We know how to get rid of negatives, okay? There's actually 2 ways in math we tend to get rid of negatives, not just erasing the negative sign. One of them is the absolute value, and the other one is squaring things, okay? The thing is if we do something to this data, we also have to be able to undo it. That's why we square things here, because we know how to undo squaring things. How is that? You take the square root, right? Doesn't squaring things and then taking the square root undo each other? They're inverse processes. All right. So what that tells us is, hey, we're on the right track, but these negatives got to us. So here's what we're going to do. We're going to square each of those terms. You don't even have to write this down yet if you don't want to. And then we're going to find the average of those. How do you find the average? Well, you add them all up, and then you would still divide by n. You see what I did? Okay? Now, how do you undo squaring things? Square root. So, you would take the square root of all of that, and this is the general method for finding your standard deviation. The rec underneath your radical is called your variance. okay? So essentially, your standard deviation is the square root of your variance. And I'm only mentioning the variance because you will be asked to do that in your online homework, assuming you do your online homework. Okay? Now, in general, that's how we find our standard deviation. In this class in particular, though, we're interested in finding the standard deviation when we have a probability distribution table. So, if you haven't been writing, start now. Okay? Given a probability distribution table, I will ask you to compute your mean and your standard deviation. So, let's go through each of these. How do you compute your mean given a probability distribution table? You guys know how to do it. What's that called? You guys just want to play hang there. It's called your expected value. You guys, you got to know that for tomorrow. The expected value is the same as your mean, right? You take your first x value times his corresponding probability plus your second x value times his corresponding probability, all the way down the line. And the formula to get your standard deviation when you have a probability distribution table, this is the formula you need. You take your first probability, so what that does is it eats up that n right there, and then you take your first x value minus the mean and square it. Then you go to your next term. You take the second probability, that x value minus the mean and square it. And do it till you're done with the table. Now, you guys can be thankful that you have a very lazy teacher and know that when you're going to be computing these things, it's probably going to be a pretty small probability distribution table, okay? Because I don't like to have to press buttons on my calculator. Okay, so here are these formulas. Yes, you will need this one tomorrow because that was section 8.2. This is not on your quiz tomorrow. So what I would like to do now is work through some examples. Okay, we'll see how many examples that we get through today. I did bring my overhead calculator so that I can show you guys how to push these buttons on your box. All right? So if you have your calculator here, I would suggest you take it out. So, the first example that I would like to do is out of your book. And I would like to do, where is it? Number 15. Okay? Now, what I'm going to do when I do example 15 is we're going to compute the means and the standard deviations, but then we're going to talk about what the standard deviations mean. All right? I don't mean to be redundant with my words here. But let me say this to you guys. When your standard deviation is small, let me write this down over here. When your standard deviation is small, that means that your data is not very spread out, okay? When the standard deviation is small, the mean is a good indicator, and your data is not very spread out. When your standard might be absolutely enormous, where in other situations, a standard deviation of 5 might mean that you've got really tight data. So really what you have to look at in order to know how spread out your data is usually comparing two different standard deviations. Okay? That usually gives you a much better indicator. So I'm going to write out number 15. If you have your book, you can take it out. If not, don't worry. I always write down all of the relevant information. This one is investment analysis. And it says that Rosa Walters is considering investing $10,000 into mutual funds. The anticipated returns from price appreciation and dividends, this is in hundreds of dollars, are described by the following probability distributions. So she's got two mutual funds she's looking at. There's mutual fund A, and the returns versus the probability. We have -4 with the probability of 0.2, 8 with the probability of 0.5, and 10 with the probability of 0.3. Now remember, the returns are in hundreds of dollars. And then she has mutual fund B, which has the following returns and probabilities. These are given to you guys. Got -2, probability of 0.2, 6 with the probability of 0.4, and 8 with the probability of 0.4. Okay, so what this means is with a probability of 0.2, she can expect to lose $400 here. With a probability of 0.5, she can expect to gain $800. With a probability of 0.3, she can expect to gain $1,000. Remember, these are in hundreds of dollars. You guys with me? Similarly, over here with a probability of 0.2, she can expect to lose 200, 0.4, gain 600, 0.4, gain 800. You guys, as with any investment, just as much as you always hope to gain, you can lose. Okay? So, what we want to do first is the following. The first thing we're going to compute is the mean and the standard deviation of each of these. Okay? So, let's do mutual fund A first. Get my calculator out here. Do we know how to compute our expected value here, or our mean? We absolutely do. Okay, so for mutual fund A, don't you take each x value times the corresponding probability and add them up? Hopefully you know that for tomorrow. So what do we have? We have -4. Darken that. -4 times 0.2, and please use your negative sign and not your subtraction sign, plus 8 times 0.5 plus 10 times 0.3, so we get 6.2. All right, in other words, the expected return for mutual fund A is $620. You guys with me there? Now, we can do the exact same thing with mutual fund B. And I claim you're going to get 5.2. I've done the computation. You would do it the exact same way. -2 times 0.2 plus 6 times 0.4 plus 8 times 0.4. Everybody with me this she would get $100 more from mutual fund A as opposed to mutual fund B. You with me this far? All right, now what I want to do, well, not necessarily want to do, but now what we need to do is compute our standard deviations for each of these, okay? So, what I'm going to do is I'll show you how to write this out, but more importantly, I'm going to show you how to plug it into your calculator. I mean, and it's enough of a pain with a 3-column probability distribution table. So you'll see why I keep them small. So for mutual fund A, here's the formula for it. You take the square root, you take the first probability, then you take the first x value, you subtract the mean, and you square it. Then you take the next probability. You take his x value minus the mean, and you square it. And last but not least, we'll do that to our third term. So do you see how I plug that into my formula? Now, let's practice pushing buttons in our calculator. Okay? Some buttons you need to be aware of. Where is your square root button? Mine is diagonal to the left from my number 7. Okay? And it's actually the second button because my x squared is the first. Okay? So I would hit second x squared and I get that square root. Notice, when I do mine has a parenthesis. Okay? If yours does not have a parenthesis, put one in. All right, now you just type it as one long strand. So what do we have? We have 0.2. Notice I've got a parenthesis over there, so I'm going to put my parenthesis. I have -4 minus 6.2. I close that parenthesis, and then I square it. Plus, I have 0.5, parenthesis, 8 minus 6.2. I close that parenthesis and square it. And last but not least with this guy, I have 0.3, and then I have 10 minus 6.2, and I square it. I'm not done. You guys see how I plugged it in this far? Now, the thing is, your calculator likes to keep track of parentheses. You see how I had this beginning parenthesis? He needs a partner, right? For every parenthesis, he needs his partner. So you got to close the parenthesis at the end. And that tells your calculator, yo, you're taking the square root of this whole big mess. Ta-ta-ta-ta equals 5.173. If I didn't take the square root, that would have given me the variance. Or you could just square this answer and that would give you the variance. All right. Well, let's now compute the standard deviation of mutual fund B. Would you like me to write it all out down here? Or just plug it in my calculator? Does anyone want me to write it out? Sure. Okay, then I'm going to do it. It's the square root of, okay, I'm doing mutual fund B. I take my first probability. I take my first x value. What's my mean for this guy? 5.2. And square it. Plus my second probability. My second x value minus the mean and square it. Plus the third probability and my third x value minus the mean and square it. Now do you guys see why I said this is like a great quiz type thing, but not for a test. I mean, one wrong button on a calculator. So let's compute this. I do the square root, and so I have 0.2. Now I put my parenthesis, -2 minus 5.2 squared, plus 0.4. Then I have 6 minus 5.2 squared. And last but not least, plus 4. And I have 8 minus 5.2 squared. What do I need to remember to put at the tail end? My last parenthesis. And you're going to get 3.71. I'm not done discussing this problem, but I want to ask if you guys are with me to this point.
The first number, 5.2, was the mean.
Yeah, remember when we...
Second number is the standard.
The second number is the standard deviation, right? Mean is 6.2 SE. I'm going to be giving you guys different notation for each of those shortly, so let's just let them keep out. Everyone okay? All right. So another question then that's asked is the following. In which investment would the element of risk be less? That is, which probability distribution has the smaller standard deviation? What are you going to tell me? Who's smaller, 3.71 or 5.17? This 3.71 is much smaller. So notice, while our expected returns are higher for mutual fund A, mutual fund B is less risky. And that actually translates to real life, okay? I don't happen to play the stock market, but I am aware that essentially the safer investments, the less risky investments, tend to bring a lesser return. Whereas you tend to make more money on the riskier ventures. Okay? All right. So let me just go through one more example. We're not going to do another computational example right now because we don't have time to push all the buttons on the calculator. I will do one more computational example on Friday in class. But let's just pretend we have this, just so that I can give you another idea of the standard deviation. Okay? So, cereal boxes. People sometimes buy boxes of cereal. Okay? Machines fill up the boxes of cereal. Machines do mostly now, it seems. But what does the cereal box usually weigh? So 24 ounces. Okay, let's pretend our cereal box claims that it weighs 24 ounces. Okay? Well, do you really think that if you weighed the cereal, every single box would weigh exactly 24 ounces? No, of course not. I mean, different machines fill differently, okay? So, suppose we have two machines for this company. We have machine A and machine B. And, you know, it really doesn't matter what weight they fill it. Suppose you looked at a bunch of cereal boxes that were filled from machine A. And how about the average weight was 25.6 ounces? And let's suppose that the standard deviation was computed, and you got about 2.4. And suppose machine B had a mean of, say, 24.3 ounces. But the standard deviation was like 5.7. This is about the type of situation where we can start reliably fills around its particular meaning. Machine A is a lot more consistent, if you will, with the way it fills the cereal boxes than machine B does. Okay? Why? Because the data's more spread out here, and so it's less reliable and less consistent. Yes, conceptually, your standard deviation is essentially your data's average distance from the mean. Okay? So really, it's most useful to look at a standard deviation if you can compare it to another. Kind of, yes. All right. You guys okay? So, here's my request for you guys. It's the following. Please try to play with your calculator with this stuff, just so that you're familiar with pushing buttons, so we don't really have to belabor that next time. But next time, definitely have your calculator here, because you're going to want to